Good evening, everyone. Welcome to the Global Math Department. My name is Lee Natero, and I will be the host for this evening. Right now, I would like you to introduce yourself in the chat room window. We are a friendly group, and we would like to know where you teach, and what your Twitter handle is if you have one. I see some familiar faces in here this evening. And tonight we are truly a global community because we do have people from Australia with us tonight. As a matter of fact, that is where our speaker is from. Looks like we have other people from Australia, as well as people from North Carolina and Tennessee, California, Canada, Washington. Welcome, everyone. So while we're waiting for the last few introductions to come into the chat window, let me tell you a little bit about how these meetings work. These meetings are recorded and are available a few hours after the meeting ends. To view the recording, you would come back to the same URL you used to get here tonight. The Global Math community prides itself on being friendly and supportive. The chat room is available for topical and general conversation throughout the meeting. I'll catch your questions, so don't worry that the presenter won't notice them in the chatter. Our speaker tonight is John Rowe, and John is a math teacher from Adelaide, South Australia. He currently works at Desmos as a computational layer specialist, and he also runs a professional learning program in his local area. Earlier this year, John released Hook, Line, Sinker, a free resource ebook for mathematics teachers. He's passionate about finding ways to harness the natural curiosity students bring to the classroom, and he likes to present learning in enticing ways. Welcome, John.
Hello, how you going? Can you hear me all right?
Yep, we can hear you.
Yep, cool, awesome. Welcome everyone. I think the Australians have taken over the Global Math Department, or as it will be known for the next hour at least, the Global Maths Department. All right, are we nearly good to go, Lee? Are you still with me? Yep. Okay, yeah. Cool. All right. Let's get started. So we're going to be doing, the way tonight's going to work is that I'm going to be screen sharing. So hopefully this goes okay. I've also got two little puppies in the room as well. So hopefully they don't bark during any points of the webinar or need to go outside to go to the toilet. Anyway, enough of that. Let's get started. So a little bit more about myself just before we get started. Like Lee said, I'm from South Australia. I have been teaching maths for a few years, although I don't currently have a class. I'm currently working with senior maths teachers, so that's teachers that teach year 10 to 12 or grade 10 to 12. And yeah, for the past couple of months, I've been working for Desmos as a computation layer specialist. And yes, it's as fun as it sounds. Alrighty, let's jump right in. So a colleague of mine started a presentation with her beliefs, and I thought I would snatch that idea from her because I thought having an idea about where some of these ideas come from can kind of help the audience understand, you know, the thinking behind it and the rationale behind it. So the way I like to think about maths is quite similar to how I think about food. One really important thing about maths, I think, is that it tastes different to everyone. This can be hard to remember at sometimes. I mean, for instance, I love truffle. Anything truffle, I'm having it. When I hear that others can't stand it, I'm astonished that someone else couldn't like it, and naturally wonder about their deficiencies. It's really hard doing a webinar because I can't see your faces, so I'm not sure if you're truffle fans as well. But I think there can be sometimes some similarities and parallels with maths. I kind of wonder how anyone could, you know, how can you not like the things that I like? And for us maths teachers, we might actually have a lot in common with that too. Maths is also like food because what you like depends on what you're used to. My mum's Filipino and my dad's Australian. So when mum started adapting her cuisine to suit the Australian cuisine as well, we had all sorts of random dishes come up. So I thought it was quite normal to have rice with your pizza or your spaghetti or literally anything, even with your coffee. So what you like definitely depends on what you're used to. I think this is applicable for all students in our classroom, and for us as teachers, the implications are quite wide. Maths is like food. If it looks good, I'll be more likely to try it. For this one, I do actually mean if it does aesthetically look enticing, I'm going to be more likely to actually give it a go. That's something that I believe at the moment. It's not something I've always believed, but I do find that a lot of students do kind of feel the same way a lot of the time. Maths is also like food. It's really good for the soul. And I think this is, people that are passionate about anything would say the same thing about their passion. Maths just happens to be my passion. Food is also a big passion of mine. But I guess it's a close second, and it's also just that feeling of trying something out, playing with an idea I've got a little knowledge about, and testing it out for myself in a fun way. And lastly, and probably most importantly, is that everyone should have access to it. Access to high quality instruction, I think, leads to high quality learning, just as nutritious food leads to better health. We're going to hopefully hit all of these today, and we'll start from the top and probably just work randomly through it. Okay, so you're my brand new class, and I need to know what your taste buds are like. We're going to jump into a Desmos polygraph activity. So if you've done one of these before, excellent. If not, also excellent. This is something I'm sure you'll go straight back to your class and try. It's like a maths version of Guess Who. What we're going to do is just do some pre-work before we open up any class codes or anything, just to make sure we're 100% ready to jump in and play. All right, so let's see how we go with this. All right. Sorry guys, just sorting myself out. Okie doke. So there we go. So the way the game works is similar to Guess Who. Players take turns asking each other yes/no questions about graphs to narrow down their options and hopefully find the one their opponent selected. Since we're going to be replacing people of Guess Who with graphs, I'm going to prime us with one graph for those who might need those who might be a little bit more rusty with their graphing knowledge than others. Okay, so you can see that this is a set of axes I've got up there. And what I've done is just put up a line there. Actually, in the chat window, if you could just throw up some words that might be helpful in describing what's going on in this graph. So what are some words that might be useful to know? Let's just put up line. some handy vocab that might be useful when trying to describe what's going in here. Positive slope, pink, yeah. Increasing. Slope, positive slope. Diagonal. Excuse me while I just read the stream. Wow, okay, getting negative x-intercept. Awesome. X gets bigger, Y gets bigger. Really specific things here. Uphill. Increasing at a constant rate across both axes. Okie doke. So when I was preparing this, I was anticipating that I was going to be presenting off PDF. So it meant that I had to preempt a lot of the words that you might have come up with. Things that I thought you might have come up with were increasing and decreasing. Maybe not decreasing for this one, but that would be some handy terminology to have. X-intercept or Y-intercept, X-axis or Y-axis, perhaps slope or gradient, bringing in some different ways to describe maybe the same thing. Quadrant, which I did see in the stream as well, and maybe the words positive and negative used in some way. So I'm sure we can all value how useful these words are, which is precisely why when we play the maths version of Guess Who, I'm going to ask that you don't use words like increasing to describe a word like this, a line like this. I'm also going to take away the word decreasing. X and Y intercepts are a thing of the past, as is everything else. Okay, so to be crystal clear, these are the banned words. When you're playing, I'll be keeping a close eye on anyone that is using these words or any others that seem mathematical. So when I go to the next screen, a class code will appear. Now, when we're doing this, it's probably going to be pretty important that you open a new tab and you keep this one active. That I'm hoping will allow you to still have audio so that you know when to come back, and also you don't have to, try to find the link again. So when I do put up the class code on the next screen, you will need to open up a new tab, type in student.desmos.com, and then chuck in that class code. Alternatively, I could probably chuck a direct link into the chat room for you. Okie doke. So remember, these are the banned words. Okay, I'm going to put them up there as well. These are the banned words. What I would suggest is that if you have done polygraph before, that you actually just skip the tutorial. And I'm going to jump over here. All right. Refresh my page to see people. Okay, I can see that we've got 4 students in so far.
And if you're having trouble remembering that code because it's late on the East Coast, just copy and paste it from the chat window, and that'll work too.
Okay, there's a direct link. Okie doke. So you got plenty of people. Oh, all right. Some people have started up. I'm going to anonymize you as well, just for now. I usually have that automatically done, but as you can see, I'm underprepared. So the anonymize feature for those playing, for my students all know each other outside of the maths classroom. So I actually find that they care more about how well their question is phrased if they are anonymized and they don't know who is. going to be answering their questions. Okay. Just a reminder, we do have a banned words list. Okay, so any word that is on this list, you are not to use. If anyone asks you a question using one of those words, I do ask that you actually respond as I don't know, just to kind of uphold the rules I've made for you guys. I can see someone's used 2 of the banned words. It's really interesting ways that people are describing what's going on here. Some people just going, yep, I'm just going to use those words that are behind those lines there. I don't really care for rules. You do you. So each week at Desmos, we do a show and tell, which often looks like people of the faculty running an activity. What I've learned through that is that, and some of you probably already do this, a really nice way to not annoy students or aggravate students when you're going to pause the class is give a bit of a countdown when you're going to pause. That's something I previously didn't do, and I actually enjoy annoying my students and realizing that they're angry that I'm pausing them from doing maths. But if you don't want to do that, or if your students have particularly good aim, then I would suggest counting down. All right. Some really, really interesting things here. Okay, just going to pick a couple. Alrighty, folks, I'm going to be pausing this in 10, 9, oh, there's long to count from. Let's just go from 5. 5, 4, 3, 2, 1. Okay. So I'm going to ask that you come back to the Global Math Department tab. Okay, so hopefully you can still hear me. If you can still hear me, it means you've got a tab open somewhere. So it's the one that says Big Marker Webinar Room. You want to click on that. Okay, and what I'm going to try to do here is share my screen so we can have a look at some of these excellent questions you all were asking. All right, so let's go here. Okay. Makes it a bit bigger. All right. So, collective groans. Okay, so can you see what I'm seeing? Can someone just say a yes or something in the chat room, just so I can? Okay, thanks, Lee. All right, so let's have a look at some of these questions, because these were really quite interesting. Does your line start or end in a corner? No. Okay. Does your line go straight up and down? No. Is your line only in one section? I'm learning about how bad I am at reading. Yes. Is your line on the right side? So what I can see here is that despite not having any of those words, we can still talk in a way that is intelligible to another person. Intelligible just means that you can be, what you're saying is you're able to be comprehended by another person. What's ironic is that I'm struggling to explain intelligible in an intelligible way, but essentially we can communicate without having any mathematical terminology and still get by, right? So that's a good example of that. Let's go to another example that I picked out. This one here, let's have a look at the language here. Does it cross near the center? What do you think we mean by the center in this instance? What's one thing that we could describe as the center? How might a mathematician describe that, perhaps? I think some people might call it an origin. So it might be this middle point here where these axes cross over. Does it slant from the lower left to the upper right? Oh, what do we mean here? What do you think this person is trying to ask them? Does it slant from the lower left to upper right? So I'm thinking lower left to upper right, and it's slanting. So maybe, is your line increasing? Okay. Is it close to vertical? Is it close to vertical? So close to vertical, I'm looking at probably, I don't know if you can see my cursor, but the lines in, let's go row 1, column 2, or some of these other ones towards the middle here. And does it go through the center? Which is probably linking back to the other question here. So sometimes when we're trying to describe something, we don't have the right words for it, we find a way to describe it that can sometimes be easy to understand, and sometimes it's a bit more subjective. When my students were doing this, I definitely found that there were a lot of similarities. And I've got some of my students' games here as well. I've still got on anonymized here, and we've actually got 45 students in our chat room at the moment. When I did it with my year 8 students on a Friday afternoon, we had one less than that. We had 44 students. So I had 44 year 8s on a hot Friday afternoon in Adelaide. And I thought, you know what? Let's jump on and get them playing polygraph. Like a lot of teachers I know, that when they've run this, it goes down a lot better than they expect. And students do, when you set some pretty strong ground rules, they do respond quite well to it. Okay, so let's have a look at the questions my students were asking. Does your line take up 2 squares? Yes. So they understand what they mean by 2 squares. What do you think they might mean by 2 squares? I think they might mean these quadrants, because I don't know if any of the lines go through only 2 of the smaller squares that might appear on the grid. Is your line straight? This is actually a very common question asked. Is your line straight? And this one actually didn't make sense to the person trying to answer the question. So I don't know. All right, is your line straight, pointing upward, not diagonal? So maybe what they actually mean is your line straight, pointing upward, not diagonal? Is your line vertical? Right, okay. Does your line go diagonally? So in other words, does it have some slope? Does your line take up 3 boxes? Again, referring to these boxes, maybe the quadrants. And then is yours on the bottom row? These students at the time didn't realize that the cards get scrambled and happened to still pick the right card. Now, what we can see here is that if we look at these kind of questions my students are asking, and those questions that you guys were all asking, I don't know if there's much difference in the sophistication of the words or the way that the graphs have been described. With my students, I definitely did not have that banned word list I put on you all. In fact, I was like praying that they would actually bring some of those words with them. So rather than starting with all of these words here and crossing them out, I was hoping that, perhaps we could, bring those to the fore. Naturally, that just didn't happen. So we didn't actually have any of these words here that I've got on the right. Instead, students were describing this as going up, pointing upward, angled, going at an angle, going from bottom to top, going higher at the end, going diagonally, going from corner to corner. And what they're all trying to say was that, is it increasing? My students actually were probably frustrated in a similar way that you were when you had the words taken away from you. They felt they were inefficient with the questions they were asking. Some didn't, but some definitely did, especially when they described it in a different way than how they had, then maybe their partner had described it, when there wasn't this common language to link us all together. So what we did instead of starting with the banned word list, we wrote up every way that every different way the students described what was happening with this line, and said, okay, let's all agree that to make things easier, we'll use the word increasing. Okay, so when you think it's going to go up or pointing upward or angled or going at an angle or going from bottom to top, we're going to say it's increasing. The immediate thing that then happened was some students were saying, well, I think that's decreasing. I think you could actually say that that's decreasing. And then we had a conversation about how you might read what graphs do. We said things like, okay, well, if I read it like a book and go left to right, I can see that line gets higher. So I'm going to say that's increasing. Some other students said that if you look at it and the person starts on the left and they move to the right, they're going to be walking uphill. And we can kind of tie some of those things to what the students naturally bring with them through their observations. So we crossed those things off and we said, okay, now we're only going to be using that word increasing. We then brought in that banned list as we needed it, so that when students needed words like decreasing, intercepts, origin, axes, all of those different words, we brought those in. And instead of having a banned word list, what we did, we had a required word list. So students had to use at least one word from the board that we had put up. Naturally, there are things like vertical and horizontal are not on that list at the moment. So if students said, I need a word to describe this, can we add vertical or horizontal to the list? We have to go, okay, let's gather everyone else's words that they use to describe it and determine the best one that we can all agree on to move forward with. I think the power here actually comes in, instead of providing a piece of terminology and definition, I'm looking to harness that student definition and attach some sort of terminology to it to provide some efficiency for them. So they can see that maths creates efficiencies when used in the right way. most importantly, I'm hoping that I develop the need to actually learn, use, and have some of these things in our toolkit so we can say to someone, is that line increasing? And they know what I mean by that. Students will always, like me, get X and Y mixed up. But if they can understand that some of these other words, specifically like quadrant, gradient, some of these things can help you describe something quite specific, that can be really, really handy. So we did that for about 40 minutes. And then, so that was, we started our lesson at about 1:40 p.m. By about 2:20 p.m., I'll show you what our game started looking like. So this is the same class. I can even verify that it's the same class code. Okay, so if I have a look at how they did afterwards, this is where their games went to. So about 40 minutes later, students' games was then using words like, is your line increasing? This student responded as yes. So I was jumping for joy when I saw this, because this is not one, but two students that understand what the word increasing means. It's a huge, huge thing for my students at that time. This is the first time they'd ever seen linear equations. Is your line intersecting the origin? That is like a killer combo of maths words. Line, intersecting, origin, they've used it. And what's even better is that another student in the class understands what they're saying and said, no. Is your line in quadrant 1 and 3? Not only do they know what a quadrant is now, they know the weird way in which they've been numbered. And no, so again, another student understanding what quadrants are. Is your line horizontal? Question mark. Maybe the student is using voice to text and being really specific about where they want capitalization. But you can see here how we've moved, and yeah, 40 minutes of our time has moved questions looking from this here, does your line, and some of these questions are still, quite handy, but we can see that we're becoming a lot more specific, and hey, our questions per game has actually decreased. All right, so we can see that terminology helps build efficiencies in terms of communicating mathematical ideas. Awesome. All right, we're going to shortly jump into the next little activity. Okay, so for this next activity, you might need something to record on. Okay, that thing to record on might be, digital or physical. But what we're going to be doing is we're going to be estimating some slopes of lines. Okay, so you're going to need to be able to keep a record of your answers. Just to remind you here, the slope here is how steep a line is going up or down when you read it left to right. All right, so I'm just going to close this down, close that. Okie dokie. So just to remind you, all I'm going to be asking you to do is estimate the slope of the following lines. What we're going to do initially is just keep your own record of your answers, all right? And then we're going to give you an opportunity to share your responses after. There are going to be 4 different lines I'll show, okay? So you can choose to give this like a numerical response if you want. Okay, so if you think the slope is 5, estimate it at 5. Okie doke. So we're going to go ahead and I need you to estimate the slope of the following line. All right. Okay, so estimate the slope of this line and record your response. Okay. I'm going to be putting the next one up in 3, 2, 1. Estimate the slope of this next line and record your response. Okay, I'm going to be putting up the next line. I'm going to need you to estimate the slope of the line and record your response. 3, 2, 1. Okay, so estimate the slope of that line. And I'm going to be putting the final one up in 3, 2, 1. Okay, so estimate the slope of that line and record your response. Alrighty. Okie doke. So it's answer time. All right, so what we're going to do with the answers, I'm going to put up the answer and then, I'll put up the line. And then what we might do is just simply throw up your estimation in the chat room. Okay, so what did you have for A? What did you have for A? Feel free to throw that slope up into the chat room. Okay, a lot of people getting 1. M is equal to 1, 1, 1, 1 over 1. Nice, Jules. All right, a lot of people getting 1. Awesome. Okay, so, and if you didn't get 1, maybe you're going, hey, now I think it's 1. People have kind of convinced me. And if you're thinking that, then you are correct. It is 1, exactly 1. Awesome. So what about the next one? Can you throw your response up in the chat room for this one here? What do you think the slope was for B? Okay, 0.5, 2/3, 1/2, 3 over 4. A lot of fractions coming out here. Decimal responses, okie dokie. 1/2. 1/2 is a very popular answer. 3/5. Well done, Lynn. I know something I've got to be working on is my reaction to answers. I can't help it. Okay, so we can see a lot of people got fractions. And interesting responses. This one was actually 1. Yes, 1. How can that be? Yeah, Rose asking a good question there. What's the scale on the axis? What axis do you talk about? I don't see any axes there. All right. Let's move on. Okay. Let's keep going forward. Can you throw up a response to C? What was you? Yeah, was I playing tricks and scale? Did you stretch it? All right, let's get those responses up for C. What was your answer for C? And I'm gonna, yeah, all right, -1. -1. All right. I'm assuming the people that wrote -1 are going to. I'm going to assume that those people also had 1 for A, right? Okay, -1. Some people are being very skeptical here. -12. Oh, David, how'd you get that? -25 on 13? Honestly, did you look at the slides before? Okay. So what I can see is that pretty much everyone on the chat room thinks this was a negative value at least. Okay. Well, it wasn't. The slope of this one was equal to 1. And no, that's not a typo. Definitely 1. This is the good copy of these slides. And I think, yep. Pretty much everyone has just left the chat room and shut off their computer. just in disappointment and anger that I think this is also equal to 1. What? What's going on here? That's not a typo. All right. Last one. Okay. Last one. D. What is the slope for D here? Yeah, you're just messing with our brains. Yeah, I'm just 0. Lee is just so unsure about everything. Yeah, it is. Things are, well, it depends. The Australian axes, are we backwards or not voting? Some hilarious responses here of people who are probably genuinely angry. Okay, so this one here, I'm hoping that you had the answer of -2. Right? You can see that, -2. Yeah. A lot of people guessing maybe 1 because of the other ones were 1. So how did you go? Give yourself a mark out of 4. And if you want, put that mark up in the chat room and let's compare results. Because maths is all about the answer, right? All right. A lot of people getting 1 out of 4. Cool. All right. And thanks for sharing. That's really interesting. Let's have a bit of a closer look as to what's going on here. So you had slope equaling 1, quite possibly for the first one. All right. If you thought that, let's put some axes to hopefully hammer that home. Yep, slope was equal to 1. That might make you feel a little bit better. Why? It looks like these x and y intercepts are quite similar. Right? They might be the same distance from the origin, which one might think would give us a slope of 1 for a straight line. Okay, that one, good start, people. Then we had this next one. Okay, so what I'm wondering is, how do these two lines, A and B, how do they have the same slope? They don't look the same at all. Well, it's all about how you look at it. Because how I'm looking at this, and you weren't to know this, was like so. That's clearly a slope of 1, right? See, I was right. And now you're right too. Okay, let's keep going. Then we had this one here, slope of 1. This just looks so wrong. But is it? When we put axes on it, yeah, it still doesn't look, in fact, it just looks so much more like -1. It still looks wrong just having that slope equal 1 placed on that graph like that. So let's chuck some axis labels on it. Oh, what the heck? What are these X's and Y's doing? Let me make things a little bit more clear here. I don't know if that's made anything more clear. So here I'm saying this is positive Y and negative Y, and positive X and negative X. Oh, what's going on there? I think my mouse just freaked out a bit. Okay. So here, what's going on? Well, we can see that we just need to rotate this graph a little bit, right? This positive Y belongs up here. This positive X belongs down here. This negative Y belongs down there, and this negative X belongs over there. So what I'm going to do, I'm just going to rotate this around, okay? Rotating it around. And now we can see, hey, that looks a bit better. Let's rotate those labels as well. And there, we can see slope of 1, all right? I'm just going to unrotate so we can see what happened. Okie doke, rotate that around, and we can see that has X and Y in the right spots. Cool, slope of 1. All right, we've got one more to go, and here it is here, slope of -2. You might have cottoned on by now. Can we just do the same thing that we did to others? And if we did, what would that look like? Where would these axes need to go? Well, one place they could go is like this, okay? A little turn leads us to this here. Voila. All right, now some of you might be thinking, what the heck was that? That, my friends, was your first taste of truffle, an acquired taste to some, Others love it straight up. But like I said earlier, maths is like food. What you like depends on what you're used to. So this little activity came to me when I was trying to think of ways to ask more challenging questions to get my students to graph a straight line. My friend Andrew at Desmos helped me turn this into a Desmos activity. And what we might do is, just for a little moment, I'm going to get you to crack open a new tab, and I'll pop up the links for these activities at the end. But I'll get you to go to student.desmos.com, and I'm going to give you a new class code. All right, just so you can have a bit of a play with it, and maybe if you're cruel enough, run it with your own students. Okay, so here's the new class code. And I'm just going to jump some screens around here to jump onto that. And I'm going to stop this teacher pacing. I'll anonymize you. All right. And I'll put a direct link into the chat room as well. Okay. So while you're doing that, it definitely is an activity to start off with. All right. So, and I probably should have mentioned that this wasn't the next thing that we went to straight after doing polygraph. This is one that I actually haven't run with anyone before. So you guys were the first ones to have a crack at this. And I like doing this kind of stuff with maths teachers in particular because they're quite confident with their, generally quite confident with their mathematical ability to start off with. So there's a bit of room to play there. For some of my students, I definitely do feel like I run out of activities or questions, good questions to ask to challenge them to graph a straight line, especially when they've found a form that they're fairly comfortable with, which is great. But it's just about getting that extra challenge a bit higher, and also perhaps just throwing them something that they might be enticed to play around with. So here you can see that the interaction kind of allows you to do that quite easily. I use this idea of drawing the axes quite a bit when teaching trigonometric functions. So getting students to change the domain and range of things rather than redrawing the curve every time. And I do similar things with quadratics as well. But I was intrigued to try it with the straight lines. And what I quickly realized was that when you're playing around with slope, quite often you're tempted to rotate those axes around. So just a little, I guess, extension, enrichment, however you might want to phrase it. Obviously used with great caution. But you know your students best. All right, I can see some people working through quite well. All right. Just a reminder, this activity is definitely not affiliated with Desmos at all in terms of, apart from the fact that it's using the platform. Okay, this is an activity I created before starting there, and I actually haven't played around with since. It still runs pretty well. All right, I'm going to be pausing you all in about 5 seconds. 5, 4, 3, 2, 1. Okay, just a reminder, I'm going to be putting the links to the activities in the chat room or somewhere at the end of this session. I guess you will be able to access those. I mean, you could also just Google Rogue Planes. All right, so I do need you to come back to the Big Marker webinar room. Okay, Big Marker webinar room. So that tab that you had open before. Okie doke. And we're going to jump into the next activity. All right. If you haven't realized now, I do like running activities with teachers. Okay. For this activity, activity number 4, you're going to need something to write on, something to write with. And as I would say to my students, a pen, a pencil, or a writing utensil. And this is the second to last activity we've got planned. And perhaps if you've got a choice for the penultimate activity, maybe you want to use a ultimate pen. All right. And lastly, you're going to need an open mind, or a little clue, an open middle mind. All right. Let's do it. Let's jump right in. Okay. So hopefully you got something to write on, write with, and think with. So some of you might have seen this before. Here we can see we've got 4 coordinate pairs. I know some people also refer to these as ordered pairs, and there's probably other ways to describe it as well. Whatever you call them, those blanks need to be filled in with some numbers. Those that are familiar with open middle could probably, might even be familiar with this specific question. So the way we're going to fill the blanks is we're going to use the digits 1 to 9 without repetition. Okay, so we can't use a 1 and a 1, 2 and a 2. We can't use the same digits within the ordered pairs, and you can't use them across them. So I can't use a 5 here and a 5 here. Okay, so no repetition. We need to fill the blanks such that a straight line that passes through point A and point B has a positive slope. Okay, and then using 4 different numbers, we need to fill the blanks in C and D such that a straight line through C and D has a negative slope. So maybe you want to have a crack at this on your pen and paper at the moment. And if you want an extra little bit of challenge here, perhaps you want to have a go at trying to find the steepest slopes possible. Purely in the interest of time, I'm going to go through what my students did. Okay, so I made this for my year 10 students, grade 10 students, who should be fairly familiar with coordinates and straight lines. In Australia, our curriculum is written so that we actually teach the same thing kind of over and over at different depths across different year levels. So this is something that I was kind of I was surprised with how much they struggled on this task. And we'll kind of dig deeper as to why in a bit. All right, so my students, like a lot of open middle problems, approach this thinking that, there's blanks there to be filled, so I'm going to fill the blanks. So they did that. And they went 1, 2, 3, 4. And I went, yes, correct, well done. Okay, and then they went, all right, cool. Well, if that's true, then 5, 6, 7, 8. And I went, incorrect. When I told them yes, but not C and D, I got a little nibble at the end of the line. What I mean is, like, some of the students, their ears kind of pricked up when I said no. They were actually surprised that their method of 1, 2, 3, 4, 5, 6, 7, 8 didn't work. not because they think that should work for all, but 1, 2, 3, 4 works. So why shouldn't 5, 6, 7, 8 work? So what they then did was they tried this. All right, well, if that's the case, I'm going to swap around what I had for C and D. And they said, how about this? I said, I think your thinking there is pretty good. Your thinking is going, well, in maths, when I reverse things, it kind of, it reverses other things. So I'm feeling that if I swap these two around, that should give me, if I had positive before, it should give me a negative now. And then here was where I really I hooked them in by telling them they're essentially wrong. And I kind of felt as though I just wanted to say to them, you're not thinking enough. Here is where a lot of my students actually stopped to make sense of the problem. So when they were going, all right, well, that didn't work, now what? They actually had a read through the question. And I think this is something that happens to a lot of the students that I teach, is they'll be given something and they'll see, fill the blanks, sure, and they'll just jump in and go straight to it. And they won't actually stop to realize what they were asked to do. That, yeah, they needed a positive slope, okay, for the first one, and that they needed a negative slope. A lot of my students actually didn't graph this out to have a look, but when I did provide them that prompt to go, well, have you thrown them on a graph to see what it looks like? A lot of sounds came, going, oh, that's so obvious. Why didn't I think of doing that? And I think it's because they didn't stop to make sense of the problem. I think at this point here, when they realized, well, what should go here is when this turned from an exercise into a problem. I think the students have then found, there's something to solve here. There's something I'm going to have to think differently about that I haven't done before. So when I say, coming back to my beliefs, maths is like food, everyone should have access to it. There are some students that just didn't have the tools to make sense of the problem in the way that, perhaps you or I would make sense of this. So what I did, I essentially went on to Desmos, surprise, surprise, and took one of their pre-existing activities and just made it fit my open middle problem. So this helped consolidate this task for a lot of students and see that or get something out of the task that they might not have got had they not stopped to make sense of it. So the last little thing, if you were to go to student.desmos.com and enter the class code ZNZC2T, you should be able to access that last little one. Okay. And we've got a couple minutes left to explore this, which is awesome. Okay, so with a lot of Desmos activities, you can actually go and copy and edit, and that's essentially what I did with this, and I just made it fit my problem. Okay, so perhaps what I might...
The code again for that one, John?
Oh, whoops, sorry, my bad. There we go, thank you. And I'll pop that direct link into the chat room as well. Sorry, folks. So with this, if you're looking at screen one of the key moves here is that those points are automatically plotted for them. Now, this is something I did after, or I'd suggest doing after students have actually had a crack at doing the open middle problem. And even students that solve the open middle problem itself and have no issues with that, I think still get something out of the later screens of this, as well as the earlier ones. Some students just applied the slope formula straight onto the points that they had created with their open middle problem. and kind of got some answers spitting out pretty quickly, which is great. But making that connection and just taking their thinking a bit further with the help of a task like this, can really support that consolidation that I sometimes struggle to get in the classroom. Okie doke. So again, I'm going to put these actual activities up in the chat room later on. But according to me, that's 11:30 a.m. my time, which is meaning that we're coming to the end of this webinar, which seems like it's been really quick for me. So I'm going to pause the class. I'm sorry, guys. In 5, 4, 3, 2, 1. And I need you to come back to the big marker webinar room just so I can say goodbye to you all. Okay. So that was the final activity. And what I really hope is that some of my beliefs came through the design of those tasks, but also the selection and how I use those tasks. And I hope that was kind of conveyed. I'm not going to lie, it's pretty hard to talk to the computer rather than people through a webinar, but that's just part of the challenge. So thanks for coming. You can tweet me online, which is the only way you can tweet someone, I believe. Or you can search. One thing that I like to do for the Australian contingency is tag things hashtag MTBOS, which is an Australian take on the MTBOS. I've also got a free ebook for maths teachers, which you can download from mrrowe.com/book. Or if you want to email me, john@desmos. And most of all, the most important thing that you need to remember is that maths is like food. It's good for the soul.
All right. Thank you very much, John. There are a lot of activities there, and you're right. I think we definitely could have spent more time working through some of those things and thinking about those. I would just like to announce what we're having coming up next week. Our presentation next week is building visual patterns into your warm-up routine, and that is going to be presented to us by Fawn Wen, another great person to follow on Twitter, another great math teacher. So I hope those of you that joined us this week might be able to also join us again next week. And if you cannot join us, remember that you can always get the recordings about 24 hours after the webinar is over. Thank you very much, John.
Thanks, Lee.
Could you put up the link for the ebook there again? Good evening, everyone. Welcome to the Global Math Department. My name is Lee Natero, and I will be the host for this evening. Right now, I would like you to introduce yourself in the chat room window. We are a friendly group, and we would like to know where you teach, and what your Twitter handle is, if you have one.